You may have watched a video on why you would want to work out the area under a curve. We now move on to why would you want to work out the gradient of a chord or a tangent to a curve. But before we do that, I think it would be wise just to spend a little bit of time recapping how you work out the gradient even of a straight line. So let's remind ourselves that the gradient of any straight line is the change in the y values divided by the change in the x values. And we're going to work out the gradient of this line segment here. We have a point at 2, 5. We have a point at 8, 25. And the gradient, the change in the y values. Now you should know that it's important to be consistent. If I'm going to say 25 take away 5 for the change in y, then I must move in the same direction for the x values. I must then say 8 minus 2. If I want to be a little bit awkward, because I'm going to get negatives, I could do 5 take away 25 for the change in the y values, as long as I follow it up in the denominator with 2 minus 8. It doesn't matter which way round you go, as long as you're consistent for both of them. It's also critical, I hope it's obvious, that you get this the right way up. If you decide to flip that fraction, everything's wrong. So the change in the y values, 25 minus 8. The change in the x values, 8 minus 2. It would be good if I didn't make a stupid mistake. 25 minus 5. And then 8 minus 2. And so the gradient is 20 divided by 6. If we simplify that, it's 10/3. And it's more accurate really to leave it as a top-heavy fraction rather than trying to change it into a decimal. Much better to leave it as 10/3. So that's how you work out the gradient of a straight line. Now let's think about why you would want to work out the gradient of a chord or a tangent. Over here, I think we will consider distance time graphs. And on the right hand side, we'll use velocity time graphs. And we'll focus in, first of all, just on the distance time situation. So we're going to have units, perhaps meters, and time seconds would be typical. And we've got two possibilities. Perhaps we're asked to work out an average between 2 points. If you're asked to work out an average between 2 points, you always use a chord. And that will actually be the same over here. If you want an average, you work with a chord. But if instead you want not an average, but an instantaneous value at one particular time, then instead you use a tangent, and that one is very badly drawn. That's better. And similarly here, if you wanted an instantaneous value, badly drawn again, there we go, an instantaneous value at a particular time, you use a tangent. So the first thing to be clear about is that chords, let's put this over here, chord is for an average, so that's looking at these two situations here, whereas a tangent for these two situations here is an instantaneous situation. But we haven't yet discussed what these chords or tangents might actually work out. Let's put meters per second per velocity. and see what we can deduce. So for both of these, the gradient is equal to the change in y, now that's meters, divided by the change in x, seconds, or written perhaps more helpfully like that, meters per second. This has to be talking about a speed. The gradient of a distance time curve, whether you're looking at a chord or a tangent, the gradient is representing the speed of the object. Here it's an average speed between two times. Here it's an instantaneous speed at one precise time. Now, over here on the velocity time graph, the gradient equals, well, the change in the vertical, the change in the y, which is measured in meters per second, divided by the change in the horizontal, or the x values, and that's measured in seconds. Now this is a little bit more awkward. Meters per second divided by seconds over 1, because it's like a whole number. Meters per second, hopefully you remember how to divide by a fraction. You multiply by the reciprocal. And so we get meters per second squared. And meters per second squared, that is talking about an acceleration. So here, on a velocity time graph, we're looking at a chord. So we have an average acceleration, whereas here for this tangent, we have an instantaneous acceleration. Now I would judge that if you try to memorize these four situations, you're going to get very confused. I think it's much cleverer just to know how to work out the gradient, as we did up here. You've got to do that anyway for simpler questions. Know how to work out the gradient, and then do the same calculation, but with the units. Get your answer, perhaps this, perhaps that, get your answer, and think about what that actually represents. So an average speed, or an instantaneous speed, and here an average acceleration, or an instantaneous acceleration. We'll perhaps look at an actual example in a future video.